Hi, this is the third lecture for week 8, and we are now moving towards POSIX sockets. You already know what are the basics of networking. We discussed it in the previous lecture, where I said that basically there are two things that you are really required to know in order to connect to another machine. That is the IP address of the machine and the port number at which you are trying to make a connection to. If you know these two things with the help of these socket APIs, these socket libraries like POSIX sockets, you'll be able to connect from one machine to another machine. So just a brief introduction, a formal introduction of what sockets are. So a socket is essentially an end of a logical communication session between two members of a network, and sockets are part of a protocol that operates on layer 5. So I told you that there are only two layers that you probably need to know about: layer 5, that is the transmission layer, and layer 4, that is the network layer. So you probably only need to know about these two layers and not the other layers. So this one, the sockets really are a part of layer 5. And when I say socket, what I really mean is that there are four pieces of information that are kept together. Okay, so this is, let us say you are now currently at your own machine, and you want to connect to, let us say, your friend's machine. So your local IP address and the port number on your side of the communication, that is the port number on your machine. The remote IP, this means the IP of your friend, and the remote port number, okay, the port number on his or her machine. So these four pieces of information, they constitute a socket. Okay, so these four pieces of information, if there is a difference in any one of these four, then it is considered a different socket. If all four are exactly equal, then we say that the two sockets are basically the same. But any one, if it is different, so for instance, if everything is the same, but let us say the local port number changes, so then this is a separate connection. Okay, it means that you have two connections between you and the other machine, the, let us say, your friend's machine. Similarly, if you have actually that will not be possible, but for the sake of theory, let us say that the you have two connections where the local port number is the same and the remote port number are different. Then again there are two different connections. But it is not possible, but still, like, I mean, the idea is that anything in these four, if that changes, then it's a different connection, it's a different socket altogether. So what we do is, we try to create two sockets, one at your end and one at the end of your friend. And then if they are logically connected to each other, then from there onwards you really don't need to know any details about the underlying underlying communication medium through which this connection has taken place. So from that point onwards, you can then start sending data, and the data will be received at the other end, and from the other end the person can send data and you can receive it. So that is the crux of the matter. You need to first establish a connection, and to do that you need to create two sockets which are, let us say, which are matching sockets. And then if you have these two sockets available, you can start doing the data transmission. So a typical scene whenever you are going to use sockets and whenever you are going to create logical connections using socket is something like this. You have to understand only the logical part of it, right? Don't be too intimidated by the code right now. But if you can simply understand the overall philosophy of how network connections are made, that should be fine for now. Okay, so for communication, as I said, you need two parties, right? Two machines should be there, and they must be connected to each other. So there has to be a physical connection somehow. Okay, so that is the point, that there has to be some communication medium. It could be across multiple hops. Okay, but don't assume that two machines which are physically disconnected from each other, they cannot send data to each other. Okay, so that is something that you have to take care. For example, if you have a machine that is connected to a Wi-Fi router that is not connected to the internet, okay, then if you try to send data to that machine, the only way you can send that is by connecting to the same Wi-Fi router. If you try to send it via internet, that machine is not reachable. So that is the idea, that basically physically it should be possible to there should be some kind of physical connection between the two machines. It can be across multiple channels, but via some hopping you should be able to reach from one machine to the other, to the other. And then we say that these two machines can be connected to each other. Now out of these two machines, this is important, one plays the role of a server while the other becomes the client. Now, please keep in mind that the term server here doesn't really mean servers as in those big, huge machines that sit in data centers. Okay, no, we don't really mean server in that context here. In fact, your own laptop or even a small VM on your laptop could act as a server in the communication, because the only expectation that is there from the server entity is that it is online whenever it is required, right? So I've written all the time, but the idea is whenever it is required, it should be online, it should be available for accepting a connection. That is the only expectation from a server. So as long as this process, there is a process running on one particular machine that is ready to accept a connection, that is fine. Okay, that could act as the server in the communication. On the other hand, a client is someone who only becomes who only comes online whenever it is required, right? And then when the job is done, the client simply leaves, right? A typical example would be, let us say you are connecting to the internet using your 4G data, right? Now whenever you try to connect your mobile phone, the it should be available, right? I mean, you should be able to connect to the ISP, the internet service provider, whenever you want. But it doesn't mean that you are also expected to be online all the time. You can switch off your data and then you are off the grid. So the same thing is here, that basically you are the client and the server is the ISP. So similarly, you need two entities in a communication. The server entity is supposed to be online all the time, or let us say whenever it is required, it should be online. And the client entities, they come and go as and when they require. Okay, so you basically need one process that is executing all the time, and this is the server process. And the other process, the client process, may come online sometimes, and then get offline whenever it is required. So for the communication setup to be able to work, the server must be running before the client starts. This is the important aspect, that there are going to be two processes in this communication setup, and the server process must be running before the client process is started. So this is how a typical networking flow will happen whenever you are going to use socket programming. So first of all, there are two machines now. Okay, in theory you can have both the machines as same. In fact, not theory, you can you can have it as the same machine. I'll show you an example of how we do that. And you can communicate between two processes via the complete OSI reference stack, but both the processes are running on the same machine. That is possible, and I'll show you how to do that. But still, you have to assume that there is a different entity altogether, the server, and there is a different entity altogether called the client. So there is a process which is started on the server to listen for connections on a fixed port number. So the port number at the server side has to be pre-decided, and it has to be the same throughout the communication, and it should be known to the client beforehand. Okay, so for example, I'll tell you that I have started a web server on my machine. Now you can connect to me. What it really means is, there is a server which is it's just listening on port number 80 and or port number 443. Okay, remember the HTTP and HTTPS things. So basically the port number is either implicitly told to me so that it is fixed, or I'll have to explicitly tell this to someone who wants to connect to my machine, that this is the port number at which you must connect. So this is how it starts. On the server process, on the server end, you start a process which listen for connections on a particular port number. Let us call that port number as P, whatever it is, right? Now the same P must be communicated to the client, okay, and a process is started on client to connect to the server with the known IP, okay. So the IP of the server also must be communicated to the client, and the second thing that must be communicated is the value P. If the client knows both these things, it can attempt to send a connection request to the server. On the server, when a new connection request is received, a local socket is created. Let us call it that S server, and this S server is identified by those four elements that we just saw, right? Local IP, local port, remote IP, and remote port. So all these things constitute a particular port, a particular socket. So there is a socket at the server end. Let us call it S server, and it is logically connected to a peer, to its peer on the client side. And here let us say we call this to be S client, okay. And you have to understand that these are symmetric in nature. Whatever is local IP and local port here, it becomes remote IP and remote port here, and vice versa, okay. So they are like peers for each other on either end of the communication. Now from here onwards, once this communication has been set up, the S server can send messages or receive messages from S client, and S client can send messages or receive messages from S server. But keep this in mind that the server process must be started first, and only then should the client process be started. But once all these things have been done, once you reach this stage, then it doesn't matter who is the server and who is the client. Anyone can send the message while the other can receive, and right, and vice versa. So there's really no compulsion that the first message must be sent by server and the second message must be sent by client, so on and so forth. No, there is no compulsion. So from here onwards, it could be extempore. The any way you want, you can use the connection has been established. So now if you want to use the POSIX socket library, we've used the POSIX thread library, by the way. So now there is another library for networking. So the way POSIX actually treat sockets is very similar to how file descriptors are treated in C, right? So the first thing you do when you use a POSIX so this is actually not threads, this is POSIX networking allows you to use a socket descriptor for performing socket IO, and this socket descriptor is very similar to a file descriptor in C, right? You have to remember, you used to get that file pointers which are returned by f open. Something similar to that is there, right? So this socket descriptor is there. It is basically an integer which points to a block of let us say management data, with the help of which the socket is managed. And you can even use the read and write methods that are there for reading and writing files. In a similar fashion, you can use the socket descriptor actually. Unlike the threading library, the problem is that it's the number of function calls that you will have to make with the sockets library are far too many, and you have to deal with many different types of structures, right? So it might be a bit overwhelming for you to try it out on your own. So what I have done is I have created two classes for you, two utility classes for you. If you are planning to use networking in your project, you can actually pick these two classes. They are very basic. It's not like I've done a lot of things, but yeah, I mean, if you want, you can use those classes to send basic messages from let us say a client to a server and vice versa. So we'll have a look at the code in at a very higher level only. We are not going to go into the details. So the only idea is that you understand how typical networking programming flow works, okay. It is not to teach you in detail what exactly are the library functions. So in a typical POSIX workflow, this is what you really do. These are the methods that you are supposed to call on the server end, right? So basically, I told you that there are going to be two processes. So now you are going to have at least two programs. Okay, one will run on the server side, and the other program will run on the client side. So in the server side program, you need to call these functions. The first function is the socket function. It creates a new socket descriptor based on your preferences. So these preferences include things associated with what protocol that do you want to use, and so basically this is more like boilerplate stuff. You'll often use the same thing for a call to socket, as long as you are doing this TCP thing. So basically TCP is the protocol that we are going to use. So it uses so this function call is about telling the library what kind of protocols you are going to use. Then it returns a socket descriptor for you to use. Then this socket descriptor is bound. Okay, it is attached using the bind function call to one particular port number. So you remember, right, that the server must listen on a specific port number, right? So the attachment of this socket with that port number is done using the bind call. Then the next thing you do is that you mark this particular socket as a listening socket, as in this is a socket which is probably a passive one, right? So it has to run in the background, expecting a connection. So the operating system allows it to simply keep on running in the background, and expecting it to be to and expecting that someone is going to connect to this socket. And then you call the accept method. This accept method is basically the place at which your server goes into a kind of blocking state. Blocking as in, so now when as soon as you call accept, the only time when the accept call will return is when a new connection has been received. So until that happens, the accept call basically blocks. Okay, so the control blocks then and there whenever you call accept, and it will only go ahead once a new connection request has been received. So this returns whenever the new connection is received. It again returns another socket descriptor, and this socket descriptor is the actual socket with which you are going to talk to the client. It will have a different port number, by the way. And we do that because we need to keep that other socket, the one with the specific port number, to be free. So we create another socket on the server side, and then we start the communication between us and the other side. And then there are two methods, send and receive, RECV, and they can be used to send and receive messages over the network. And then finally, once everything is done, you just call the close method on these two socket descriptors, so that you can free up all the resources of operating system. On the client end, it is slightly simpler. You just call the socket call first, so that you get a socket descriptor. Then instead of bind and listen and accept, you call the connect method. The connect method requires that you provide the IP address and the port number of the server to which you want to make a connection to. And this call is again a kind of blocking call. Based on your preferences, it might actually wait till the connection is completed. So for example, the server might be busy right now. Whatever happens, right, the connect call can be made to wait for a while until the connection goes through. It returns if it is absolutely sure that the connection cannot be made. So for example, there is no route between you and the server, or that the server actively refused connection on that particular port number. In that case, the connect will return and it will give you an error. Otherwise, the connect will go through and you will receive another socket descriptor, with the help of which you can now communicate with the server. And then the send and receive methods are exactly the same, and then the close method is again the same. You close the connection that was created via this connect method. So I have created two utility classes for you, because the overall calling these methods in the exact order, handling all the cases where something might go wrong, this is slightly tricky at this point of time. So I've just created two classes for you. One is the socket class. The socket class is basically client socket class, and the instance of a socket class is the communicating entity at the client end. And to create an instance of socket, you need two pieces of information: the server's IP and the pre-decided port number. That is, these are the two things you need to know. And then you need to call a function in this class called connect to server, and it will do that. All those method calls that all those function calls that were there, they are done in this particular method. The server socket class is going to be the entity at the server end. So remember that there are going to be two different socket instances that we will create, and the only thing that you need to provide for creating a server socket is the pre-decided port number that you are supposed to listen on, right? The IP is implicit here because you are starting this on your own machine, so the IP is not really required. The IP is your machine's IP. And this once you have actually created the socket, you can call the listen for connection method, and then it will start listening for a new connection. And post connection, both these classes have these methods send message and receive message, with the help of which you can send and receive data. So let me now show you some code. So this is the code here. By the way, I am going to use the exception handling in this code because there might be so many ways in which this code can fail. So I am using this class called socket exception. Okay, it is just extending the exception class that is there in C++. This is a generic class, and it is a good practice that if you are creating your own types to handle exceptions, a good idea is to simply extend this particular class. So that is what I am doing here. It only has one field to store the message of the exception, and then it has a method to get that message out. So now I have created these two classes socket. Okay, sorry, I think it is already open. This is the socket class. In the socket class you can see, okay, let me just make it like this. So in the socket class, there is one descriptor for that particular socket, right? The socket descriptor is in some ways similar to the file descriptor. Then you have this. There is this socket server address thing is required for communication. Don't worry much about it. We'll just check out the C++ code. So here you can see in the constructor I am calling all those methods that I talked about. So this is the socket method, the first method that gets called, and then here in the connect to server method I am calling the connect method. So these are the two methods that I said are required at the client end. So whatever parameters are required, they are being supplied here. From your side, you only need to provide me the IP and the port number. And then after that there is a method called send message, and then there is a method called receive message. Okay, send message, you send a string to me. The string has to be 10, it could be 1024 characters long, actually 1023, the 1024th character should be /0. So basically you can send a string up to 1023 characters using this method, using these two pairs of functions. And the receive message basically says that I'm expecting a message from the other end, please read it and send it back to me. Similarly for the server socket, um, here you can see that in the constructor I've only provided the port number, and then the way these calls are made are: the first call is to socket, the next call is to bind, and the third call is to listen. So this is how this is the flow that I talked about. And then when you want to start listening for a connection, this is the accept call, and this is, when you'll call this method listen for connection, as soon as the control executes this line, your program will go in a blocked state, right? So basically it'll go and halt there. Okay, now it is accepting, it is now listening for new connections, and you will only come here once a new connection has been established, or something happened, some error happened, because of which you had to abandon your listening. But in most cases, if you reach this line, it means that a connection has been established, and from now onwards you can use the same send message and receive message functions in order to send and receive messages. So now I have two test classes. This is the sample server class. Actually, what exactly is, let me, I've probably forgotten the name. Yeah, it is uh, the server test. And by the way, you can keep the server code on one machine and the client code on another machine. It should work. The only place where you'll have to change is when you create the client test. So basically, here when you are creating a socket instance, here I am providing 127.0.0.1. This basically means my own machine. This is a special IP address that says my server is running on the same machine as I am running on, and this is the port number. So if you want to run your server on a different machine, you can take the server related code there, run the server application there, and then you have to change the IP address, okay, to your server's IP address. And so here what is happening is it is creating a socket to the server, then it is calling the connect to server part, and once the connection goes through, it sends just a message hi from client, and then it attempts to receive a message from the server. Now this part you will have to figure out that the actual synchronization of messages, who will send, who will receive, how does it happen, this is up to you. You have to devise your own mechanism to to figure out when will when and how the communication goes through. I'm just showing this to you to figure out that this is a two-way communication channel. Okay, you can send a message from here which gets received there, and vice versa. Similarly, the server uh, test class, the only thing you need to do is create the server socket class and just the port number. Okay, you don't need to provide the IP address because that is implicit here, and then you need to call the socket.listen for connection. So once you start this program, your code, your control will come and halt at this point of time, unless a client request comes up, right? And then from there onwards, I'm just trying to receive a message from the client and then send a message to the client. So if I run this, let me start the server first. That is the idea. Sample server. So you can see that this is in some kind of a waiting mode. The program hasn't really exited. Okay. So what really has happened, that accept call, that is where it is currently listening for a new connection. And now if I create, if I run the sample client now, you can see that something came here, hello from the server, and this program has also completed, right? So why? Because basically I just wanted to show you one end-to-end connection. So as soon as I started the client process, the new connection was made. It received a hi from the client and it sent a hello from the server to the client. So here there are two programs which are running, the client and the server, and this is how the communication takes place. Okay, so just try to understand, just try to run this code to get an idea of what exactly is happening. Okay, thank you guys, bye.